Once more, hello everyone. I'm Agata. I'm employer brand specialist here at Cyclone. We are actually a global digital solutions company delivering IT excellence to hundreds of companies worldwide. You can see, actually, we've put a slide here for you to see all of the information, as well as you're more than welcome to visit our site to learn more about our company. But for now, I think it's already time to start. There are a few of us who, hello, Petar, I hope I pronounce your name right. So actually, we can start just this kind of information at the beginning. If there are any questions, Marcin will answer them after the presentation and the demo, so at the end of our webinar. And not to make it any longer, I will give the voice to Marcin Bauda, our expert.NET developer here at Cyclone. And actually, Marcin can say a few words about himself and start the presentation.
Yes, hello everyone. As Agata said, my name is Marcin and I am working at Cyclone. I am .NET developer since 13 years. I mostly spent my career working with the web technologies, and the last couple of years there was project mostly related to the cloud. Related to the clouds. And this is why I wanted to share this presentation with you, because a couple of years ago I found with my colleagues that most .NET projects are made with cooperation with Microsoft Azure Cloud. And I was starting thinking why it happens, why only Microsoft Azure Cloud is chosen by developers and architects when they create projects with .NET platforms. When I asked my colleagues, they told me that because they have support, they have tools prepared from Microsoft, it's easily integrated with Visual Studio, and in general, this is Microsoft stack, so it's easier to create solutions using Microsoft Azure Cloud. Then I was starting learning AWS, and I found that it's not true, because as easy as to create solutions, .NET solutions with Microsoft Azure, as it's possible with AWS Cloud. Yeah, so I prepared some brief presentation to prove it to my colleagues, and this is the presentation I wanted to share with you today. Okay. Before we start, I want to have everyone on the same page. So briefly about serverless. Serverless is an architecture of systems, of constructing systems and running application and services without infrastructure management. It's not without the infrastructure at all, but without infrastructure management. Yeah? Many of people is laughing that serverless, but there are servers somewhere. Yes, there are some servers, but we don't have to think about those servers. We don't have to manage those servers. We don't have to update the systems, and we don't have to do anything about the infrastructure. Yeah, almost all major cloud providers like Azure, Google Cloud, and AWS have their own implementations of serverless. And for example, in AWS, this is AWS Lambda. Google Cloud have cloud functions, and Azure functions. Yeah, all of them, there are implementation of function as a code. Couple words about the AWS Lambda. AWS Lambda is something like a runtime for our functions. Lambda function, this is a code we can create and deploy and run on the AWS Lambda environment. Is more often called function as a service, as another level of cloud services. This approach like all serverless approaches, is pay as you go. Yeah, so we pay only when our function is processing some data, some requests. When there is no working Lambda, we don't have to pay for it. So this is the difference between the containers deployed on virtual services deployed in containers or virtual machines run in a cloud. We have two significant factors which have impact on our payments. The first one is the time when function is used. So we pay only for time when the function is working. And the second is memory allocated for the Lambda function. We can allocate the minimum value 128 megabytes, and we can as well allocate 1 gigabyte of RAM memory. So the pricing depends on the memory size, but you have to remember that more memory is usually shorter time of processing data. So the balance between the allocated memory for every single function and average time of working the function is something what we want to achieve to have the best payments. I mean the minimal payments. There is something like free tier. Free tier is a very good solution for every developer who wants to start working with AWS Lambda and learn it, because we have some minutes. We don't have to pay for them. As well, this free tier is working for production solutions when we don't have too much requests, we don't have too much working Lambda functions. If our traffic, if our processing is inside this free tier, we don't have to pay for this. So sometimes it may happen that we can create Lambda function, we don't have to pay for it in entire month. So this is a very interesting solution. Serverless and AWS Lambda have its own pros and cons, like almost every technical solution. Scalability is the huge, is a huge benefit of the Lambda function and all serverless solutions. But there is something like cold start. I will show you the cold start later when I will run the demo. Cold start is a problem we need to solve, and it's related only to managed code like .NET or Java. When you create your own services with Node.js or Python, the cold start is very minimal and sometimes doesn't appear. So the cold start is a problem we need to resolve. There are different patterns, different solutions how to work with that, and I recommend to read some articles in internet when you start working with Lambda and when you think about going on production with Lambda functions. Scalability, as I say, this is the huge benefit of serverless solutions. I believe almost everyone, or maybe everyone, knows what scalability means, but to have everyone on the same page one more time, I will explain how it works in AWS Lambda environment. When we deploy our Lambda function, it's not run. Yeah, this is only the code deployed in a package, and it's waiting for the first request. The request can be sent from a number of AWS services like Kinesis, like SQS, which is a queue service, SMS, which is application service, or API gateway, which is a gateway for the REST HTTP requests. And this is something we will use today, and we can use to create our REST services. So when the first request come to the Lambda function and there is no instances running of the function, AWS will create the first container with the the Lambda. I'm say container, but it's not the Docker container. There are internal implementation of containers of AWS. So the first container is created and launched. When it's running, the request is transferred to this function. It's processed, and when there's some response, the response is sending back. Depends on what our Lambda does. So when another user or another client, because it doesn't have to be the user, that can be mobile or web client or any other type of client, will come with the new request. The Lambda function, and the Lambda function is still running, then the request will be processed automatically immediately when it comes to the API gateway, because the Lambda function is not shut down right after the processing is ended. I couldn't find the value of time, the amount of time when the Lambda function is still working, or maybe waiting, better word, waiting for the new request. But sometimes ago I heard it's about 15 minutes. Yeah, so 15 minutes the Lambda function will be waiting for the new request. When the new request will be processed immediately. Result will be returned, and the Lambda function will be waiting for another request. When no request appear during this time, this idle time, then the Lambda function will be destroyed, and in the case on the new request must be created from the scratch. What happens when more than one client tries to send a request to our Lambda functions? Depends on the configuration. AWS can create another instances of our function. Yeah. So when there will be huge amount of requests or huge amount of messages in SQS, for example, if you in SQS service, then new instances will be created. But we need to remember that every creation of Lambda function is related to the cold start of this particular instance of Lambda function. Yeah, so the cold start will appear for every single instance which is created, and the first request will be redirected to this Lambda function. When there's a huge amount of requests, the number of instances will be created, the requests will be processed, and results will be returned. Yeah, when the Lambda function, then another instances of function are not used, they are still waiting and not processing any data, AWS will take a decision to shut down some instances, and will be after some period of time will be automatically decrease the number of working instances of Lambda function. So the shutdown process destroy all the instances for us. We don't have to manage them. We will not be paying for those instances anymore. It may happen that for some period of time no requests appear, then all instances will be deleted, and there is no working Lambda function. Yeah, so the next request will trigger to creation a new Lambda instance. So this is very easy and comfortable solution for us. We don't have to spend too much time. We can just configure how many instances we want to have in maximum, how many instances we can create at the time, and so on. So there is a matter of configuration and nothing more. The all work is done by AWS. Okay, what is the Lambda function? Lambda function, as I said, is a code we can create to process some requests, to process some data. This code consists of three things. First, this is the function handler. Function handler is the entry point for our Lambda function. This is something like webhook, which will be triggered by the event. As I said, event can be different type, but every event can deliver some data to process, and those data are packaged in event object. This event object can be custom type that can be just .NET framework type that can be some type delivered by AWS. I will show you later. And we have another object which another object, this context object. Context object contains mostly something, some metadata like function name, instance ID, but the very interesting part of this context object is a logger. We have access directly to the cloud logger. For example, that is CloudWatch. We don't have to install any other framework, any other logger. We can use it on the very beginning and use the CloudWatch for free with our Lambda function code. What about the security? Maybe you know there's something like shared security model. Almost all cloud providers prefer this solution because the part of the security we are responsible for, and for other security is the cloud provider responsible for. I mean, we are responsible for delivering the proper role and policies to Lambda function. We can define what resources can be accessible by the Lambda function, what external services can trigger our function. For example, that can be AP gateway or SQS, but we should avoid to using policies with full access, for example, because it means that our Lambda function can use every other service in the AWS, what may bring some problems when credential, for example, leaks out of the project. And as I said, our Lambda may but don't have to return some object. Yeah, we can return some data, return some results of processing. It depends on what is the scenario of the business logic. Okay, this is the sample I have prepared for today's demo. We're gonna prepare two very small Lambda functions which will deploy and expose externally through the AP gateway to the world. That will be accessible through the HTTP protocol as a normal REST service. As a database, I'm gonna use DynamoDB. This is only for example that we can cooperate from our Lambda function with other AWS services. And what is interesting, the DynamoDB is as well serverless solution in AWS cloud. Okay, but before we start, we have to prepare our environment. What do we need? We need an AWS account, so we can create it for free. But when we create our account, we have to add some payment details. Usually, this is a credit card, but we can create some limits for spending our money. For instance, on the account I have prepared for today's demo, I set the maximum limit of spend money for $1. So for, most of the time I'm working for free. .NET Core 3.1. I suggest you to use the latest version of .NET Core because the previous one, 2.1, is not going to be supported by AWS in the near future. So I recommend you to create the newest version. Visual Studio depends on the version you have, you can use, starting on 2017. And I recommend you to install AWS Toolkit for Visual Studio. It's not necessary, we can work without it, but it helps us, supports on the very beginning, on the first, when we do the first steps with AWS Cloud and AWS Lambda. For example, we have some bunch of project templates. We have a visual tool for deployment, for doing deployment from the Visual Studio. We have AWS CLI. This is a command line interface. Most of developers prefers to use such tools, and this tool supports us with deploying architecture and infrastructure and code from CI/CD tools, so we can integrate our CI tool with AWS Lambda using this AWS CLI. Then we don't have to do deployments manually. This is the normal scenario from, I believe, every project. AWS SDK for .NET. This is SDK delivers some libraries you can use in our code to communicate with AWS services and resources. So as you may see, it's not true that only Microsoft Azure has support to work with the Visual Studio. We have a bunch of tools we can use for every single day. And I believe there are not all, because there is AWS SAM, for example, for serverless application model. There are any other tools we can use. But there are this is the minimum set I have used for my today presentation. Okay, time for demo. As I said, we have to start with creating an AWS account. When we create such account, one of the first things we have to do is to create credentials we will use in our service to communicate with the cloud. Sorry, not in our service, in our computer to communicate in the cloud. Yeah, we have to have authorization credentials. How to do that? I have created users. One of these users is called Martin, and this user is used to do today's presentation. For this user, I have created security credentials. I have access key, and this is another security key. What is important, this security key is visible only during the creation time. When we don't save these credentials, it's not possible to take a look on this security key and reuse it. Then we have to inactivate this credential and create a new one. How to configure it on our local machine? First, you have to install AWS CLI. I did it, and then we can use AWS configure. After that, you have to specify your AWS access key. As you may see, this is specified access key by me because I prepared it for this presentation. So I'm not gonna replace it by the same. But the next step is to provide AWS secret key. All those informations are stored in some text file in our computers. I just wanted to present you that we can store credentials for more than one account. So we can create something what is called by AWS profile. I have two profiles. One is default one, and second is Martin. So I can use many profiles. I can store credentials for many profiles, and works on different parts of system or maybe for more than one project from the one computer without any problems. The other part of the configuration, and this is the next step of this configure process, is to define the region. Define the region you want to use. It's optional value, but you can specify it. Will be sometimes easier to communicate, because when you don't use that, you have to provide it manually for you by you. Okay. Let's say we are prepared. I'm not going to replace those data. Then we can start work with the Visual Studio. I have prepared some solutions, so I will be not creating from the scratch. but just to prove what I said. Sorry. I can share with you the list of the projects which are at this moment accessible from my computer. I have installed toolkit for serverless. So we have two main templates. One is for Lambda function project, and second is for serverless application. What is the difference? For Lambda function, we can define only the function, and only the function will be deployed. For serverless, we can define and use more serverless services, not only Lambda function, and we can deploy all of them at once. I will present it in a minute. I have two Lambda functions. What is the domain? Domain is very easy, and I believe everyone is familiar with. This is the BMI calculator, so I have to provide some data like height and weight, and based on them, my function calculates my BMI ratio and returns information if my body is healthy or not. So we have two functions. One calculates this BMI, and second returns those data. As you can easily guess, the first one that will be triggered by the post HTTP method. The second one will be triggered by the get HTTP method. So, as I mentioned, we have something like function handler. This is my function handler. So this is the function. This is the entry point for my Lambda function, and the function handler contains two arguments. This is the input data, this is the event object, and this is the I Lambda context. This is the instance of the interface I Lambda context, which contains, as I said, many information, for example, logger. So I created, I called it CloudWatch logger, but I just created my instance of logger based on the context. So as you may see, the context contains an instance of logger, and I only prepared the wrapper of this logger to have some shared methods to log error or message. And I don't have to do anything more. This logger will be working with Lambda CloudWatch, which is the log service for aggregating our logs. And I used lambda.core namespace from Amazon SDK. Okay, here is some business logic. It's not interested for us. And as I said, we can return some results. So at this moment, this result is just my calculation result, custom object created by me. And as I said, the event object can be just .NET Framework, any .NET Framework type. So for example, here it's a string. We are waiting for item ID to get the item from database. And we, one more time, return entire item. So this is the object. Okay, this is there are two functions. And this project is dedicated to Lambda function. I could create two separate projects for two functions, but I have one project with two functions. It's not a problem. When I want to publish it manually without CLI, I have integrated tool for publishing my Lambda function from the Visual Studio. It's a good solution when you learn, because you don't have to jump to the console or use any external tools to do the deployment. What is important, and it doesn't, no matter what environment you use, is CLI, it's Visual Studio, you have to specify some values before you do this deployment. First, the account profile, we need to authorize authorize our request that we are the person who have access to this account and can send some new resources for AWS Lambda environment. So I use the default account because during the default, I have the credentials created yesterday. So this is the default account and region. For this example, I have choose Europe, Ireland, but it doesn't matter. I can choose any other region. This is a group of language runtime I can use. At this moment, I am using .NET Core 3.1, so I'm gonna use this one. Then we have to specify our function handler from the end. Method name, this is function handler because this is how my method is called. Type name, this is the assembly name from our solution, and function name, so here's the assembly name, and type name, this is the structure inside the assembly. Function name, this is the name of our function which will be visible in AWS console. Of course, we have some configuration and framework one more time. I'm not gonna do this deployment one at this moment because I will present you the second approach with the SAML script. This is the serverless application model. We can describe more than one service, more than one infrastructure element, and deploy everything at once. This is exactly the same, the same function. I only use different project template. This is the project with the sum. And here I have additional file I don't have in the Lambda function project template. Serverless template is the simpler version of CloudFormation template. What is the CloudFormation? CloudFormation is a service who allows us to create entire infrastructure for our solution as an infrastructure, as a code. The SAML is a simple version for serverless solutions. We don't have to use entire CloudFormation features, just create a simple script. This is, as you can see, JSON script, and this script will be used to create the entire infrastructure and during the deployment of our Lambda function. What we have in this script, as you can see, at this moment I have two functions, so it means I can deploy all functions at the same time. I don't have to prepare script for every new function. Let's take a look on the function. First, we define what is the type of the resource you want to create. This is the serverless function. It's quite obvious. Then this is the handler, and here we have everything in one property. This is the assembly. This is the namespace in the assembly, and function handler. This is the function name. As well, we have the specified runtime environment. Here, I have specified memory size. This is memory which will be allocated for our every instance of Lambda function. So every instance of the function, of this function, will be created with 128 megabytes of RAM. This is some timeout. We need to wait for processing. When the timeout expires, the exception will be thrown about the timeout. Yeah, so we can define the timeout when we know that the processing shouldn't take more than some interval of time. We can specify it, and this is the information for us that when the timeout appears, there's something wrong with the request or Lambda, or maybe it's not enough memory. This is something we can configure here. Policies. As you remember, I said that we have to provide some security information for our Lambda function. In this situation, I don't use role. I have used policies. And this is the practice I don't recommend you. I use it only for purposes to to omit the Murphy's laws, yeah, because usually when we create something on live or we do live coding, something goes wrong. And to avoid any potential problems with policies and security, I decided to use the full access policies. But this is something I don't recommend in the production project. Events. As I said, the Lambda function can be triggered from the different events. In my situation, this event is a type of API. It means that that will be just REST request sent to my Lambda function. Maybe it's not true that the request will be sent to the function, but the request will be translated to the internal communication protocol, and the Lambda function will be triggered. But from the external, that will be HTTP request. I will show you it in a minute. We decide we define the path and method which will be used to trigger our function. This is something we have to define for every REST service. Similar situation for the second method. The only difference is I used 1 GB of RAM. There's the different function, and the method will be get. Yeah, the endpoint path is exactly the same. What is more interesting here, I have added one more resource, AWS resource. This is the calculation DynamoDB. This is just DynamoDB, new table in DynamoDB. The type, this internal definition of this type is a simple table. There is no SQL database for storing our documents. In my situation, that will be requests with calculation results. Table name, and so I specify the primary key. There's only one key, nothing more. So the definition is very simple. So I can deploy this solution. Let's create new stack. What is a stack? When we deploy infrastructure, there is a stack in CloudFormation service created, which contains all information about our infrastructure, about last modifies, about updates. And when we want to delete the entire infrastructure, what, for example, may be a scenario when we learn something new, or when we work on the test environment and we want to drop this environment, we just need to delete this stack from the CloudFormation service. You don't have to delete every single resource, every single service separately, because it may take some time. We may forget about something, and then costs will be to pay in the future, because not all resources are free when are not used. Yeah, so this is very easy option to manage our infrastructure from CloudFormation service. S3 bucket, because we need to upload to the cloud our code and information about the infrastructure. I mean the serverless template script. We need to define the place when those packages will be stored. S3 bucket, for people who don't know, is simply storage service in AWS cloud. So I have prepared some storage. I just created a new stack, and I choose the region Ireland. So let's go with publish. Now we can see the progress of publishing. The package is prepared and will be uploaded. When the package will be uploaded, automatically will be redirected here to the panel, which, as you can see, is integrated with Visual Studio, with containing all information about deployment process. Yeah, so when we don't use any CI/CD tool, for example, when we learn something or prepare some proof of concept, we can monitor the process of deployment here. I hope it will pass, because I did some changes before this this presentation. I know I shouldn't, but I did. Okay, what we see here. Lambda function is created, DynamoDB was created, some permissions are in progress, creating of permissions, API gateway deployment is completed. It seems it will be working, I hope. Okay, create complete. We can go to the AWS console and take a look what is the result of our work. Let's start with AWS with the Lambda. Okay, I'm in Frankfurt region, so let's switch to the Ireland, where I have deployed my Lambda function, and we have two Lambda functions deployed before the mainnet. When you go to the Lambda function, you can see that it's related to the API gateway. API gateway will be triggering our function. There is a lot of information here. We can do monitoring, we can do the testing of our function here, but I'm gonna test it from the endpoint from API gateway. So let's go to the API gateway. Not redirecting, so let's go here. In the meantime, I can present you the cloud formation calculations 24. Yeah, this is the stack I have created before a moment. So entire infrastructure can be managed from here. I'm not gonna talk about it right now because there's no time for do that. I just wanted to present you. Okay, API gateway. We have created API gateway. And as you can see, under the API calculation path, we have two methods, and those two methods are connected to our Lambda functions, get and post. Let's start with the first one, the post. Here's a simple flow of our request. The request from the client come to the API gateway, then through the integration layer is or proxy layer is redirected to our Lambda, which is connected to our endpoint in API gateway. What is the integration? As you have seen, my Lambda function doesn't have any information about the HTTP protocol, doesn't have any information what method will be triggering this this function, what is the payload sent to this function. Yeah, this is just some custom type created by me, and we have to convert this request, HTTP request, to our Lambda function. So when we want to connect our Lambda function with API gateway, we have to use a type delivered by Amazon. This is part of SDK. This is API gateway proxy request, and we have to respond using API gateway proxy response. The proxy layer just translates the HTTP request on those objects, and when the when the Lambda instance is created or is running, those objects will be this object will be delivered to the Lambda function as a request. Yeah. This is just a wrapper for the HTTP request, so we can use it, for example, to get the data. I use just JSON converter to deserialize data from the body. The second method, for example, can read the value from the query string. So this is something we know from .NET Core and REST services created in .NET Core or ASP.NET Web API framework. Depends on which one you work with. Okay. So this object is delivered to the Lambda function. Lambda function does some work, and through the integration response returns some data here. Let's do the test. I have prepared some payloads, so I use one of it. Oh, okay. We didn't check if the data, if the DynamoDB table has been created. Let's refresh the page. It should be here. Yes, we have calculations, and this database does not contain any item. Okay, great. Let's go back here. Request body. I can send it. Sorry, test. And as you see, we have to wait a lot of time. And still waiting. This is the cold start. Yeah, this is how much we had to wait to just run very simple Lambda function, because entire .NET Core environment is launched in the AWS container inside, and we have to wait when everything is done and the Lambda function can be working. When I run it one more time, for example, we can hear this request. Yeah, this is the same request. So when I run it one more time with different data, the result is returned automatically, because the Lambda function is still running, is still waiting for the new request. So we can deliver new requests, and Lambda is processing it automatically. If I had time and spent here, for example, 15 or 20 minutes and run this request one more time, the cold start should appear one more time because the Lambda will be shut down. So the function will be shut down. Okay, let's take a look on the response. We have some response. BMI has been calculated. For those data, the body type is normal. And we have information that it's be stored in DynamoDB with this ID. Let's take a look. DynamoDB. Now, it's one more time, Frankfurt. Yes. Oh, because I've sent 3 requests, so we have 3 items here. So it's okay. We can take a look on it. Just JSON view. It's better for everyone. We see that the item has been stored in DynamoDB table. The same situation when I use the get method, I can just take this DynamoDB item from database and just return to the client. API Gateway allows us to do more things. We don't have to use the URL specified by AWS. We can attach our domain. We can attach some certificates for SSL, for example. So we can create the REST services for the function we need. We can communicate with functions we have deployed in the AWS cloud. We can use this as a infrastructure and without any problems with management, with updates of operating system, of certificates. It works for us as a serverless solution, entire thing. As you have seen, only what I had to prepare was the serverless script and nothing more. After deployment, we can use those tools. I think that's all I have prepared for today. About Lambda functions, we can talk much more things because there are layers. We can talk about testing it locally, just invoking the methods. We can talking about end-to-end test. We can discuss how to manage the function triggered to different services like SQS, SNS, Kinesis, and so on. But this is the very basic scenario you can use. You can try at home if you have never have experience with AWS and serverless solutions in this cloud. This is something very interesting, and as you have seen, it cost me nothing. I'm not sure if I have access to the billings, but if yes, then I can show you that I don't have to pay anything at this moment. Zero, zero, zero. Okay, total cost in dollars, zero. So I have tried a couple of functions. I have created database. I have created API gateway to manage my REST calls, and I don't have to pay anything at this moment. So this is very interesting solution, especially for everyone who don't have any experience in this. So thank you for listening me. I hope it was valuable for you. And if you have any questions, I am open.
Yes, please do. If you can unmute yourself and ask the questions, or you can write in chat if you want for Marcin to answer.
Hey, Marcin.
Hi.
Thank you for a very interesting presentation. I don't have like a very technical or specific question, but I was wondering, how would you compare, like from your, let's say, user perspective, like an experience with AWS Lambda in comparison to Azure functions?
Oh, okay, this is this is question I heard a couple of times about which cloud is better, AWS or Microsoft Azure or maybe Google Cloud. Yeah, I think it's very similar from the developer point of view. It's almost the same. Yeah, we have the same tools, we have the same practices. The huge difference is only with naming and with managing them in the portal, in Azure, Microsoft Azure portal or AWS console. It's called AWS console, this portal, but I don't feel any huge difference. I would to share with you the problem with cold start was discovered in AWS Azure as well. I know that there are solutions to work with that. I know that the scalability works the same way. We can expose the Azure functions through the VPNs and gateways externally to the world. So it's almost the same. Yeah. From the technical point of view, it doesn't. There is no huge difference between those two services. Yeah. The problems sometimes may appear with configuration. Sometimes may have. May differences with costs. Yeah, I'm not able to tell you right now how it looks with Microsoft Azure the costs at this moment, because Last time I worked with Azure Functions, that was 2 or 3 years ago. Yeah, so I'm not on time with the Azure costs. Yeah, but there is not huge difference. So if you have experience with any of the serverless solution, even Google Cloud Function, you will be able to work with the AWS function and Microsoft Azure function. Sorry. AWS Lambda function and Microsoft Azure function, because it's almost the same.
Thanks. There are also like interesting questions from or observations from Petar and David in the chat, so you can look at those and address them. If you could read it for everyone who's not
okay, so Peter said, .NET 6 is already supported. We moved some projects to the .NET 6 because, as they are saying in post by them, AWS, there is increase in the performance that can be caused if you are using the pre-auth, post-auth, and so on, and migrate functions because of the 5 seconds limitation of the function to get the work done. The cold start of the function is problematic if the memory is low setup. Yes, I have read the articles a couple of years ago about that the size of the memory can reduce the cold start, but as I said, when you have allocated more memory, then you have to pay more for the instancing your Lambda function. That was not directly said that the bigger size of RAM memory reduces the cold start time, but it was proven by many experiments. Yeah, so I can agree with that. About .NET 6, in my last project, the migration process not started when I was in the team, yeah, because now I'm not a part of this team. So they have plans to migrate. So I don't know about potential benefits and problems with the migration. I cannot talk to you about it because I can be mistaken. But probably you can be right. .NET 6 and Microsoft, every new version of .NET tries to deliver with the better performance. This is the one of the most important reason to create .NET Core and update it as soon as possible, to thus increase the performance. Yeah, so maybe you're right. I cannot talk to you about the performance with .NET 6. David asked, do you think a whole application backend can be built just with the AWS or the other serverless approaches? No, it shouldn't be. I recommend to, because this is the huge topic to discuss, what services could be serverless, what services shouldn't be serverless services. For example, if you need something available all the time, yeah, you have to create it and deploy as a container or as a service working in the virtual machine. If you can wait a little bit more to create the instance, because even if you create in Node.js or Python, the time for creating the first instance of AWS Lambda will appear. Yeah. So if you need something for working all the time and should be available all the time, you should probably think about other kind of deployment patterns like virtual machine or containers that can be automatically scalable as well, because all cloud providers nowadays deliver such like auto scaling for different services, not only serverless. Serverless was the first one, but different services as well supporting auto scaling. In some scenarios, serverless approach can be very expensive solution, yeah, because if you have a huge amount of data to process in one request, the time of working the AWS Lambda, for example, will be longer than we expect. A couple of seconds. So for the longer time, you will pay more. Yeah, there are two factors of the payment. One of them is the time of processing single request. So if you know that your Lambda will be working on heavy data or process some I don't know, huge streams of data, you should avoid using for such solution. But I believe it's very easy to find in internet many articles about when it's better to use the serverless approaches and when it's better to use the containers, because containers now are on the top of the tech stack. I believe serverless was was very popular a couple of years ago. Now we have containers, but every single architecture approach is good for some scenarios. There is no one magic tool for all scenarios. I hope I answered your questions and doubts.
Yeah, sure. Thank you.
So actually, thank you. I think there are no more questions at this point. I don't know if someone tried to connect a second before. So actually, thank you. Thank you to our big thanks to our speaker, Martin. He was talking for a long time and answering your questions.
Welcome.
Thank you all for joining. If there is something you would like to share with us after the webinar, you have some thoughts, please do and share your feedback. Of course, just so we know, we are always welcoming great talent in the company. So if you'd like to check our Cyclone website for job opportunities, you're also welcome to do so. And yes, thank you very much. Thank you for joining and hope to see you at another webinar.